All right, so 10-1, we are going to be graphing the parabolas that I've promised you for so long that we would. So 10-1, graphing, and the parabola's equations are called quadratic functions. Those are the equations in the form of y equals ax squared plus bx plus c. Remember, we factored all those in Unit 9? Yes. No. No. All right, so your quadratic function is in the form of y equals ax squared plus bx plus c. This is what a quadratic is, what it looks like. Now, you've been used to y being equal to what? 0. When y is 0, we find out what x is, and that's where this parabola crosses the x-axis. Because if you think about a coordinate grid, on the y-axis right here, this would be where y would be 0. Isn't y 0 all along the x-axis? Right? The y value for any ordered pair along the x-axis is 0. That's why we let y equal 0, and we find what are called the zeros, or the solutions to that quadratic. Well, now we're going to find those solutions, and we're also going to graph that quadratic. So the first equation I do with you is going to take a long time. You're going to have a lot of writing. It gets a lot faster hereafter because we won't have so much notes to write to ourselves. So if I were you, I would write exactly what I put down, right? Everything. All words. Because what's going to happen is when you go home tonight and you try to do this, it's a process that you have to learn. If you try to do this, you're going to get lost and you're not going to know what to do. You're going to give up. Brandon, we're taking notes. I'm not sleeping. All right, so here's your first equation. Y equals x squared minus 2x minus 8. There's a lot of information that we need to gather about this parabola. I know it's a parabola because it's got a degree of 2. It is not linear. Remember, linear, you don't have an exponent. All your exponents are 1. So a couple things. I need to tell whether my graph opens up or down. So that's the very first question. Opens up or down? In order to determine that, I need to find my A, my B, and my C. My A, my B, and my C. So according to this graph, what is A? The coefficient of the square term is what? 1. What's B? It is -2 because the sign associated with it's negative. And what is C? C is -8. C is your constant. When you decide whether it opens up or down, you're going to look at your A value. So look at the A value. If A is greater than 0, what do I mean by greater than 0? What kind of number is greater than 0? Yeah, but what kind of numbers are those? Positive, right? So I'm looking for A to be positive. A shouldn't be 0. If A is 0, then we don't have a quadratic. Because if A is 0, doesn't the x squared term drop out? So A will not be 0. But if A is positive, it opens up. Giving what's called a minimum value for y. And here's why. If my parabola opens up, so here's my parabola, let's just say it opens up. Here would be my vertex. This vertex, I'm going to show you how to find it in a minute. This vertex, this is your max or your minimum value. Isn't that the lowest part of the parabola if the parabola opens up? That's why that value right there is going to be, in this case, a minimum. It also creates what's called a restriction on y. The way I've drawn this particular parabola, will y ever be negative?
No.
No. Y will only be whatever this value is here at that vertex and greater, right? So whether it opens up or down restricts your y value. My x value is never going to be restricted, right or left. This parabola just keeps opening up wider and wider and wider and wider forever. It will cover the entire x-axis, which goes on infinitely in both directions, however wide you want to make it. Obviously, our paper, we can't make it very wide. All right, then what if it opens down? If a is less than 0, which would be a negative value, then it will open down. So positive is up, negative is down. It makes sense because on the y-axis, positive values are up, negative values are down. And so that would be giving a maximum value. So if my parabola opens down, again, here would be my vertex. This value here would either be a max or a min. Isn't it the highest point on the parabola when it opens down? So if it's the highest point, it's going to be the maximum value for y. Y will not go higher than that. And again, that makes that restriction on y. So what about this one? Does our parabola here open up or down with a being 1? So our parabola opens up. And you have to be asking these questions to yourself so that you have a general idea of what your parabola is going to look like. So I now know my parabola opens up. Then I ask myself question number 2. Vertex. Your vertex gives you a wealth of knowledge. So we are going to find the vertex. When I find the vertex, this will also give you the axis of symmetry. I'll show you what that is in a minute. And exactly what your max or min value is. Will somebody let Nick back in, please? Oh, thank you. So here's how you're going to find it. Your x value of your vertex has a following equation. So the x value of the vertex, not the y, but the x value of the vertex is the opposite of b. Notice that I read it as the opposite of b and not negative b. The opposite of b divided by 2a. You need to memorize that. From that, I can then plug it into the equation and find my y value of the vertex. And then once I have that, I also have my axis of symmetry and my maximum value. So let's find that x value of the vertex. So x value of the vertex is equal to the opposite, and I'm going to put parentheses for each of these variables that I'm plugging in for. What's the value of b in our equation that we're working with? -2. Notice I put in here -2. Now you could get in the habit of writing just the opposite sign of b if you want to, that's fine. So you could have just slapped down there a +2. But for your note purposes, you really need to put in the opposite parentheses -2. Because otherwise you're going to wonder, well, where did she come up with a 2 because b is negative? Okay? And then what's the value for a? 1. So I get negative and negative gives me a +2 over 2 times 1 is 2. What's 2 divided by 2? 1. The x value of my vertex is +1. Then I'm going to find the y value. So this is step 1, or we'll call it step A for our purposes here. Then step B, you're going to plug that value into the original quadratic. You're going to plug that 1 in for x, and you're going to find y. So y equals, we have an x squared, right? So here's parentheses squared. What am I going to put in there? My 1 that I got here, -2 times x again, so that's a 1, and then -8. All I did was take the original quadratic and plug in the value that we received, or we discovered for our x. What's 1 squared? 1. Negative 2 times 1? Negative 2 minus 8. What's a negative 2 and a negative 8? Negative 10. What's negative 10 plus 1? 9. So the y value of my vertex is 9. So what that tells me is quite a few things. Oh yeah, thanks, negative 9. Good thing you're on your toes. All right, so C, our vertex, so I'm going to use V for vertex, is 1, negative 9. That's going to be the central focal point of our parabola. I have to find my vertex first. From there, I'm going to draw what's called the axis of symmetry. The axis of symmetry goes through the vertex vertically. So right here, wouldn't the y-axis be my axis of symmetry on this particular picture? What it does is it cuts that parabola in half so that I could fold the parabola onto itself. Whatever's on the left side will have a mirror image on the right side. So I'll show you how to get additional order pairs on your parabola by using that axis of symmetry. So if it's a vertical line, what axis does it go through? The x or the y-axis? Let's say it's a vertical line over here. It goes to the x-axis. What's the equation of a vertical line? X equals or y equals? It goes through the x-axis, right? Vertical line, so isn't it x equals? So we're going to get our axis of symmetry. And you have to write the actual equation, x equals. Take the x value of the vertex, which is 1. There's our axis of symmetry. Then if my parabola is at 1, negative 9, and my parabola opens up, we have a minimum value, don't we? Because the vertex is at the bottom of the parabola. So we're going to have a minimum value. And that minimum value is your y value of the vertex. Y equals negative 9. This is not an equation. You could just put negative 9 there and I'd be okay with that. You don't have to write y equals negative 9. But we're taking this value here and making the axis of symmetry. And we're taking this value here and coming up with our max or our minimum value. So you take that vertex and split it up and it gives you 2 additional pieces of information. That's where we're going to start our graph. So you're ready to graph. We need a graph that goes down at least to negative 9. So I'm going to flip this, and we're going to start our parabola on our coordinate grid. So make an x-y axis, and if I were you, I would make a whole lot more room below the x-axis. You don't have to make it even. So we're going to graph the parabola. So here's my coordinates. And I'm going to put my x-axis way up high. Because I know that I have a really low vertex. So I'm going to put the steps for plotting your parabola over here to the right. So the very first thing you do when you plot your parabola is to plot your vertex. And so in our case, our vertex is 1, negative 9. So we're going to plot that to the right 1 and down 9. And you need to label that as 1, negative 9. So that's step 1. Immediately, step 2 should be to put in your axis of symmetry. So graph your axis of symmetry. And in our case, we said it was x equals 1. Your axis of symmetry technically isn't part of your graph, so we have to make it a dotted line. So I'm going to take my ruler, because you have to use a straight edge, and I'm just going to put a vertical line straight through my vertex. It allows your eyes to focus on one half of the parabola at a time. It should be a north-south line, and you need to actually label it x equals 1. That's part of the graph. If you don't label that axis of symmetry, you'll lose some points. Very picky on graphs. Is everybody writing with me? Everybody? Don't be a bump on a log and be an observer in this classroom. You don't learn as much. All right, so then from there, we can plot a couple of things. The first thing I want you to learn to identify, because you have to have 5 points on your graph, or as many points as will fit on the graphs that I give you on your homework. Sometimes on your homework, you can only fit 3 points, but you need to attempt to go for 5. So we need to find our y-intercept and our zeros if possible. Not every graph is going to be factorable. So we're going to start off with finding our y-intercept. What's the value? The y-intercept is a point that lands on the y-axis. Okay, what's the value of x on the y-axis? 0. To find my y-intercept, can I plug 0 into my quadratic? And let me remind you that our quadratic again is, I'm going to put it down here, y equals x squared minus 2x minus 8. Now you can actually see your y-intercept right now. If I put in 0 here, what happens? You get 0. What's negative 2 times 0? What's left? Does it matter what numbers are here in front of those? If I put in 0 for x, whatever c is your constant, that is your y-intercept. So if I were you, I would put here that your y-intercept is 0, comma c. C is the constant. So for our purposes, our y-intercept is what? 0, negative 8, right? So I'm going to plot that on my graph right here. Here's my y-intercept, right there. It has a, well, I guess I missed the point because I'm blind as a bat, but there you go. Right there at negative 8, right? It has a mirror image on the other side of the axis of symmetry. That's the purpose of that axis. How far is this point from the axis of symmetry? 1. You are going to plot an additional point on the other side going the same distance. So I'm going to plot 1 to the right and plot a point here. Always plot in pairs of symmetry. So I got an additional point from my y-intercept. Sometimes your y-intercept is your vertex, and so you're kind of stuck. Then you need 2 more points, and I want you to see where this graph crosses the x-axis. So part D is you're going to solve this quadratic. So we're going to solve the quadratic and find and they're called zeros or roots. So when you factor your quadratic, you're finding zeros or roots. That's where it crosses the x-axis. If your quadratic is prime, I'll show you later how to find those. If not, then we're just going to have to find points that are going to get us over the x-axis. You have to cross the x-axis. Okay? So, are there any factors of 8? Let's do our t-chart. Any factors of 8 is 1 times negative 8. Because it's negative, we're subtracting to find our middle term of negative 2. Are there any factors of 8 that subtract to give us negative 2? 4 and 2. So I've got 2 and 4. They multiply to give you 8. They subtract to give you 2. The sign of my 2 is negative. So the bigger of these 2 right here gets that same sign. What does the 2 have to be? Positive. Can I do a shortcut here? Yes. So for our zeros, we're going to let y equal 0, right? Because on the x-axis, y is 0. And then we have our 2 binomials. The x squared becomes x and x. And then aren't you going to put a plus 2, because that's our shortcut, and a minus 4. I'm going to allow you to skip a little work. Super exciting. If I set this equal to 0, this binomial right there, what will x be if I set that equal to 0? Negative 2. You're growing up so fast. And if I set x minus 4 equal to 0, what do I get? Positive 4. So that tells me that my parabola crosses the x-axis at negative 4 or negative 2 and positive 4. When you plot this on your graph up here, if these are not equal distance from your axis of symmetry, you did something wrong, so it's a check for you. So I'm going to plot a point here at negative 2 and at 2, 4, positive 4. count how far away they are from the axis of symmetry. -2 is 1, 2, 3 jumps away, and +4 is 1, 2, 3 jumps away. Are they equal distance? So we must be okay. Then you need to try your hardest to connect those 5 points with a curve, not straight lines. I'm terrible at this, but we'll see how well I do. Oh, it's looking beautiful. And score. We're done. There's our parabola. Now, it seemed like an awful long time to get one answer, right? One graph. That's why you don't have too many graphs to do. I did not do a Y chart on this one because or an XY table, because we used our Y-intercept to get 2 of our 5 points. If this is not factorable, then you're going to have to set up a T-chart. You're going to have to choose a value for X and plug it into the equation and find a value for Y. So what I would like to do is give you your homework, and we're going to do 2 problems on your homework that will require use of a T-chart. There is not 10 problems. We're going to do 2 of them right now. This is your homework. I'm going to work 2 problems with you. So welcome. Okay. So let's do this in pencil. You are going to do this in pencil. I'll do it in pen so you can see what I'm doing. But I want you to turn, and we're going to do 2 and 3 together. We're going to do 2 and 3 together. 2 and 3 are missing what? They're missing a middle term. Okay, so that's one reason why I chose these. Let's hustle it up, please. I've got to lecture. Come on, let's go. All right, so the very first thing that I want to see, can we do that at a different time? Thomas, go pick a pencil out of the drawer. I really can't talk over that. I don't want to wait for both of you to sharpen your pencils. Daniel, go ahead and ignore me.
Sorry, I was doing
it. Second drawer down. Let's go. Hurry up. All right, so the very first thing that you're going to do here is you are going to identify A, B, and C. So what is A? Everybody, what's A? 1, the coefficient of squared term. What's B? You're missing your X term, so what is B? 0. If you're missing your X term, B is 0. There's lots of sharpened pencils in that drawer. There's a whole box in there. Open the plastic box. There we go. Okay, you know what, Thomas? Be a problem solver, but you're not using my sharpener. Go sit down. C is equal to -3. Right? Your constant? What's your first question asking you? Max or min? Find the equation of the axis of symmetry. Well, let me give you a little hint. Go up here, and I want you to write, this you have to find first. So this is number 1. Then, once you find the vertex, don't you know your max or your minimum value? Your exact max and your exact minimum value? So once you know those, then step 4 would be to locate zeros if there are some that you can find. In other words, make sure it's not prime. And then 5, you can find your coordinates for your y-intercept. And then finally 6, you're going to sketch that graph. So that's the order that you should be doing those columns in. There's 6. All right, so we're going to go and find the coordinates of the vertex. Remember the formula?
Nope.
You might want to write that up here then. Coordinates of your vertex. X value of your vertex is equal to the opposite of B over 2A. So that's what we're, yes?
Where did R come from?
R?
Yeah.
I don't have an R. That's
down on number 2.
That's an A. That's an A. Is that better?
Yeah.
That's because I had the screeching of the pencil sharpener in my ears. All right. So then we're going to find the X value of the vertex. So X is equal to, and I'm going to put a little V for vertex, the opposite parentheses over 2 parentheses. I'm going to put in 0 for B and 1 for A. What's the opposite of 0? 0. What's 0 divided by anything?
0.
So the x value of the vertex is 0. How nice. That should be really simple to plug in, shouldn't it? So then you're going to find the y value of your vertex. You're going to take this equation here and you're going to rewrite it, but anytime you see an x, put parentheses. What are we putting in that x? Yeah, doesn't that 0 go in there? What's 0 squared? Okay, and so then doesn't the y value of the vertex equal -3? You cannot leave your vertex listed like that. Isn't your vertex an ordered pair? So you have to literally write out v, and then your x value is 0, your y value is -3. From there, I now know my maximum and my minimum value and my equation for my axis of symmetry. First of all, is this a parabola that opens up or down?
Down.
Okay.
Up.
No, look at A.
Either.
No, it has to open up or it has to open down.
Opens up.
A is positive. What kind of numbers are positive on the y-axis? Up, and so you'd be raising your hands up, right? So this opens up, and I want you to write that in here. And that means it has a max or minimum value. Think of it. The vertex is at the top or the bottom of the problem. It's at the bottom, so if it's at the bottom, is it a max or a min? So it is a min value that equals what? What's the y value of the vertex? -3. So the min value is -3. Then your equation for your axis of symmetry, you might want to put at the top. Oops. Hang on, I just flicked my pen. Oh, thank you, Daniel. You might want to put at the top hold that thought. Will you pass that back to Savannah? You're not actually leaving. All right, so I would put at the top here that your equation for your axis of symmetry is x equals your x value of the vertex. And you might want to put at the top of your max or min y value of the vertex. Because this is a lot of information for you to take in at once. You're not going to remember it all. You're going to have to study it. All right, so down here, did you get all that? You ready? So what's your equation for your axis of symmetry? X equals -0, the x value of the vertex, right? So the 0 went here, the -3 went here. Now, we have to figure out how many zeros, in other words, how many places this parabola crosses the x-axis.
1.
I don't know that for sure. We have to determine where's the vertex. If the vertex is above the x-axis, think of it this way. If my vertex is above the x-axis and my parabola opens up, how many times will it cross the x-axis? It's above the, if it's up here and it opens up, will it ever cross the x-axis? So that would be none. But if it's up here and my parabola opens down, won't it cross twice? Same thing happens if my vertex is below the x-axis. If it's below the x-axis and opens up, how many times will it cross the x-axis? Twice. What if it opens down?
None.
None. Now how do we get 1? Do you remember? How do we get just 1 0? If the vertex is where? If the vertex actually sits on the x-axis itself, you will have 1 0. So we're going to look at where our vertex lays. So go ahead and plot it. 0, -3. Wow, that's really super tiny. Need to break out the reading glasses. There's my vertex. All right, immediately you should be drawing in your axis of symmetry. The y-axis in this case is actually your axis of symmetry, so you're going to have to make sure it's quite clear that you have dotted a line along that y-axis. And you have to label it as x equals 0. So since my vertex is below the x-axis and my parabola opens up, how many zeros am I going to have? Below and it opens up. How many zeros? 2. So right here you're going to put 2. And we're going to actually find them. So we're going to take this equation. So here's the 2. You want to box that in. We're going to find them. So write your equation. And then remember what we let y equal when we find zeros? Write yourself a note. Let y equal 0 and solve. Okay, so then we're going to let our y equal 0, and we have equals x squared minus 3. Oh, there's going to be a problem. How are you going to solve? Once you add 3 to both sides, and then how are you going to solve for x? Take the square root of both sides, but when you take the square root of a number, what do you have to remember to do? Plus or minus. So technically our zeros are x is equal to positive or negative radical 3. Do you know how to plot the square root of 3? But the square root of 3 is between what 2 integers? The perfect square below 3 is 1. The perfect square above 3 is 4. The square root of 1 is 1. The square root of 4 is 2. So it's between 1 and 2. So I will expect our graph to cross between positive 1 and positive 2 and between negative 1 and negative 2, right? So, okay, we don't actually have zeros we can plot for sure. But what's our y-intercept? Remember how to find it. Write yourself a note. What's your y-intercept?
0.
0. What? C. What's C for us? Negative 3. So our y-intercept is 0, negative 3. So we are going to plot that because that allows us to get a symmetrical value. Oh, gosh darn. What is that? This is our vertex. So we need 5 points, and we only have 1. So now we're going to have to do an xy table. So off to the side, you're going to do an xy table. I will allow you to do some work in your head. Now let's be smart. If I were you, I would choose positive values. And don't choose really big positive values. What's an easy number to plug in? We can't use 0 because it's our vertex. So I would be plugging in 1. So if I plug in 1, and remember, we're plugging into y equals, I guess I use a different color, y equals x squared minus 3. So what is 1 squared? No, what's 1 squared? 1. What's 1 minus 3? Negative 2. So we get to plot the point, positive 1, negative 2. What would be its symmetrical point on the other side? How far is this from the x-axis? So we're going to go 1 to the left. What ordered pair is that? Negative 1, negative 2, right? So there's 2 out of the 4 additional points that we need. Now what point would you like to choose for y, or for x? I would choose 2. Don't go too far away because your problem is going to increase rapidly. So we're going to choose 2. What's 2 squared? 4. What's 4 minus 3? 1. And our whole goal is to get across the x-axis. Did that do that? If we go to the right 2 and up 1, did I cross the x-axis? Yes. If I didn't, I'd have to choose another point. Then we're going to choose our symmetrical point on the left. How far is this from the axis of symmetry? 2. So go 2 to the left, 1, 2, and what ordered pair is that? Negative 2, positive 1. Then, can't you make a nice curve with your parabola? And you're done. So that went quicker than the first one, right? Our next one will go even quicker because you're going to get better each and every time. Now, number 3. Let's do it again. This time, we have y equals negative x squared plus 7. Very first thing, a equals what? Negative 1. B equals, where's your x term?
7.
Where's your x term? 0. And then c equals 7. So we're going to start here at our vertex. So the x value of your vertex is equal to the opposite of b over 2 times a. My b is 0. My a is negative 1. 0 over anything is going to be what? So my x value of my vertex turns out to be 0. It is possible that your vertex might have a fraction answer. It is possible. Just make sure no other points would have a fraction answer. So just beware. All right, so then our y value of our vertex. Be careful when you have a negative x squared. I'm going to take that negative and I'm going to put in parentheses the squared, because that negative is not being squared, is it? Whatever you plug in for x here will always have a negative value because that negative is not raised to the second power, and then plus 7. So putting your 0 here because I got it from that. So what is our x value? 7. And so the vertex is 0, 7. Bless you. So what is your equation for your axis of symmetry? X equals, right? X equals what? 0, just like the last one. And then, does our parabola open up or down? Look at A. So it opens down. So you might want to put opens down. If it opens down, does it have a max or minimum point? Is your vertex at the top or the bottom? Top. So it's a max value of what? 7. Now we're ready to plot that vertex. So on your graph, you're going to plot to the right 0 but up 7 right there. Immediately put in your axis of symmetry as a dotted line, and you have to label it. It's got arrows on the end. X equals 0. Since my parabola opens down, how many zeros am I going to have? 2, 1, or none? 2. So I will have 2 zeros. We are going to have the same situation as the one above where we won't be able to actually plot them, but I'm going to have you work on solving it. So I'm going to let 0 be my y. And I've got equals negative x squared plus 7. So when I solve, when I subtract 7 from both sides, okay, won't I get a negative 7 on the left and a negative x squared on the right? What do you do now? Divide both sides by a negative. Don't you get a positive 7 equals x squared? Then what do you do? Take the square root of both sides. When you take the square root of 7, what do you have to remember to do? Plus or minus. So that means there's your 2 zeros. X is equal to positive, negative, rad 7. What integers is radical 7 between? 4 is the perfect square to the left, and 9 is the perfect square to the right. Their square roots are 2 and 3. So don't we expect it to cross the x-axis between 2 and 3 and negative 2 and negative 3? All right, so keep that in your brain. What is our coordinate for our y-intercept? 0, C, and isn't C 7, and isn't this again our vertex? So these two and number 1, all 3 of these are going to be your vertex. But when you flip it over here on the back, do you see how all of these have a middle term? These ones, your y-intercept is not going to be your vertex, and you will only have to then have 2 points in your table of value extra, because you're going to have your y-intercept, and then you can get its symmetrical value, right, immediately, and then you'd only have to do 2 points here. So let's go ahead and finish graphing this. So let's get our xy table. Remember, we are looking at y equals negative x squared plus 7. So be careful with that negative. This x squared value will always be negative. So shouldn't we plug in 1? Isn't 1 squared 1? But it's a negative 1, isn't it? Because of the negative. So what's negative 1 plus 7? 6. So I'm going to plot to the right 1, but up 6. And isn't that 1 unit away from the axis of symmetry? So go 1 unit to the left. What ordered pair is that? Negative 1, 6. We have to find 2 more that are going to allow us to cross the x-axis. Remember we said that our graph is going to go between 2 and 3? If I choose 2, I'm not going to cross the x-axis, am I? I want to choose 3. So be smart about your choices. What's 3 squared? 9, but isn't it a negative 9 because of the negative? What's negative 9 and positive 7? Negative 2. So we get to the right 3, but down 2. And that's 2 units away, right? Or I'm sorry, 3 units away. So we want to go 3 units to the left. I can hardly see that. There we go. And then, so that would be negative 3, negative 2. And now you can fill in your beautiful parabola. I missed a point. Oops. Done. Now you only have 4 more.